Hello, my fellow introverts. This is Stacy, your programming and test automation expert. Today we're talking about Python decorators. I'm not going to go into too many details of what decorators are. Instead, we're just going to write them and we're going to focus on the most common use cases where you should use decorators or you probably shouldn't. So if you never wrote decorators, just stay tuned. Probably you will know how to do this after this video because I'm going to explain it on the fly. And yeah, this video is a bit too long for one episode, so we're going to split it into two episodes. So next week I'm going to speak a little bit more about decorators. But now let's get on with it and try it out. So first things first, we already have some code which adds numbers. So let's go ahead and run it. As you can see, it works. But we're going to just spoil it right away. So let's put a string here, run it. And as is normal for Python, it doesn't work. So we actually have to handle this situation somehow. These situations happen if, for example, you are reading the values of those parameters from a file, or let's say they are received from a request or a response, and then you never know what the type might be. It might be a string, it might be an integer, it might be a float, or anything else. So basically, we have to handle it somehow. The most straightforward way would be, of course, to cast num1 and num2 to integer, but this is not what we want to do today. We want to do it automatically. So this is where decorators come in handy. We do it automatically. So let's go ahead and define our decorator. So what we're going to do is create a function of the decorator. So we're going to call it cast to int, pass func here, and inside of it is going to be a wrapper, args, and we return func from args. Okay. So this is the basic of our decorator, and let me explain you how it works in brief, because if you never wrote decorators in your life, then it might look a bit tricky. So when you apply the decorator to a function, so like this, then once you call the function, it works the way that first the decorator is called, your function, so add number will go here. And the values that you pass to this function will go to the arguments. And then you can actually do something here before returning the call itself. So you can, in our case, you can cast to integer. Then you actually call the function with those arguments. If you wish, you can just write the result to a variable, do something after the function call, and then return the result. This is also possible. And then at the very end, you return the wrapper, because otherwise decorator will not work, because you have to return the reference to this function as well in order for it to be magically called. So I hope you got it. And we need now to cast to integers. So we're going to go through our arguments and cast each argument to integer. I will remind you that args in Python are always a tuple. So we have to first of all cast them to list, because we're going to modify them. So let's go ahead and do this. Args equals list args. Now we're good, we can modify them, and we have to iterate through all of the arguments and modify each argument to be an integer. So let's go through them. So for I arg in enumerate args, args from index equals int arg. Okay, so we iterate from them and we cast each argument to integer and we write it down to our list. And of course we return the function. So let's go ahead and run it and see if it works. Yes, it works perfectly fine. So now the conclusion. Should you do this? I would say probably not. Let me explain you why. First of all, of course, in this case, it looks overcomplicated. You could have just casted this number 1 and number 2 to integer. But in general, even if the logic inside of the cast to integer is more complicated and the logic here is more complicated, it's not just add numbers function, then somebody in your project might come to the code and look at the add number. It will see that it receives num1 and num2. He or she will see the add number call as well. And well, it's not very clear that the things that you pass here in the call are different than the things that we actually receive here in add number. So even worse, you could have multiple decorators here doing different things, and if this developer who actually looks at the code will just look at the code of the add number function or any other function, they will not know that you are modifying the parameters, so it's going to be very, very confusing for them, and they will have to go through all of the decorators that are applied to the function when they see this surprise that the decorators that the arguments of this function are not what they expect, and they will have to read it and understand why this is happening. So this is a bit tricky, confusing, so probably you shouldn't do this unless you need it, like very, very need it. So I might imagine an example where you might use this because let's say you're handling some requests which receive data in JSON, always in JSON. This is like a feature of this API. Then you might want to cast this JSON to, parse this JSON to a dictionary each time. And in this case, probably you can use a decorator. You could just, for each data that you receive, you can automatically cast it to a dictionary. But the decision is up to you. My point of view on this is it's a bit tricky and you should avoid this unless you really, really need it. Okay, so what is a very good case of using decorators is that we can actually verify the data. So we don't modify the parameters, but we verify if they're correct. So let's go ahead and do this. Instead of casting to int, we will call it verify is int. Okay. And we will not need casting to list anymore because we're not going to modify those arguments. We will probably not need this one as well. So we will just go through the arguments. We will just need the value. And here we do if type arg is not int, raise type error. Argument okay, so we have our verification decorator, so let's try to run it. And here we go, we have our type error. Argument 4 is not of type int. So this is a very good case. This is a perfect case of using decorators. You should use them this way because this way you separate the verification from the logic of the function, and this is a very Pythonic way of doing so. You can even go further and make it more generic. So we could actually create a decorator that will accept a type which we want to verify. So let's assume that we have verify is, then we will have type int like this passed in the decorator, and then we would need to do verify is type. These guys will go inside of this function. We will rename this one. We will call it outer wrapper. And then we will have to return it as well. So bear with me, this looks a bit complicated already, but what is happening here is that we added another level of functions here, and now this still goes to the func, these guys still go to the arguments, but we add another layer where we can actually specify our value, and this integer value will go to type. And of course we have to put it here, and we have to modify our error message as well. Okay, so let's try to run it and see if it works. Yep, looks fine to me. So let's try to fix it and see if it still works. And yes, we have our result. So yeah, this is a perfect case again of using decorators. But I have one more case for you for today. So let's see how it works. So I will go ahead and just remove these guys so that we have the basic of our decorator, and I will remove our function. And let's take a look at another case. So let's imagine we have a server which we have to start, and we have a function that starts it. So let's call it start server. It will not have any arguments or keyword arguments. We will just print here that we're starting server. And then I want to write down the basic things about the server. So it's a host port, probably whether it uses SSL. There might be other things like database credentials. Well, probably you don't want to write them, but maybe database, host, and port as well. So I've created a file here with host port and useSSL information. You might have different files like this. So we actually want to read this file and be able to write this information out. This file is a JSON, so we will parse it when reading, and we will make it a dictionary so that we can work with it without any trouble. So we want a decorator that does it for us. So let's call our decorator configuration. And here, instead of type, we will have a file name so that we can call it this way. Configuration server JSON. Okay. So now what we want to do, inside of the wrapper function, we will open our file. Sorry about that. File name, naturally. File name as f. So we will do config equals f read. And we want to parse it as well. So we will do import JSON loads f read. And now what happens? We have to pass this configuration to our function in some way. So it's done very simple. So we actually just add another parameter here. So we can just go ahead and do config equals config, just like this. And naturally, our function has to receive it as well. So we have to pass config here. And then we could do print config already as a dictionary. What information did we have here? Host, port, and use SSL. Okay. And let's go ahead and run our function and see if it works. And yes, it works perfectly fine. So let's just go through it again and see what happens. So we apply decorator, which is called configuration. We pass in the file name which we want to use, which is server.json. Then the file name goes here, our function call goes here, the arguments of the functions, which are none actually, go to the arguments. You can as well put keyword arguments here if you want to, it doesn't matter. So let's copy them here as well. Then you open the file which you passed here, you parse it and put it to be dictionary, and then you return the function with the arguments and keyword arguments, which we don't have in our situation. And we also add another keyword argument, which is called config. And here it is, we have to pass it. And then we read the information from the config. This approach is quite good. If you ever wrote any PyTest tests, then you remember there are fixtures there and they work practically the same way. You can return something in a fixture and use it in your test, and this is how it's being injected, because the fixtures, they're also decorators. So this is a good example of using decorators, although just be careful, because if you pass something in Quarks which is also being passed by decorator, you will get a conflict of names. Okay, so this is it for today. I hope you find these hints useful. As I promised, next time we will have a little bit more about decorators. And I wish you a happy coding, and I see you next week.